everyone, this is an introduction to sets, theory, and Venn diagrams. And a set is a collection of similar items known as elements. So a set is always well defined. So we're going to just put well defined. That means you always know if a particular element belongs to a given set. So for example, we have two sets here. So we know that 5 is an element of A and 2 is not an element of A. Okay? If we look at A. So for B, we know that 8 is an element of A or B and 5 is not an element of B. Sometimes we say 5 doesn't belong to B. All right? So this one, let's read that. This means this is the set of numbers x such that 7 is less than or equal to x is less than or equal to 10. And this says x is an element of n, but usually you read this as x is a natural number. All right? Hence, if we do write out the set of B, that would be 7, 8, 9, and 10. All right, those are natural numbers, and it satisfies this equation or inequality. The order of elements is not important. So, for example, if I have set 1, 2, 3, that would be the same as 2, 1, 3. So you don't write it down twice. So the order is not important. Also, in a set, elements are not repeated. So, for example, if you have, write this, A, B, this is the same as A, B. Because we're just talking like members in a set. Just like students in a class. You don't need to write their name down twice if you're looking at a list. So it's like a class set. Okay, the numbers in a set. So if we look at the number in A, the number of elements in a set would be 6. Because there's 1, 2, 3, 4, 5, 6. And for B, we already wrote it out. The number in set B is going to be 4. A and B are called finite sets. All right, now let's look at common sets. Here are your common sets, and if you're getting into set theory, you've probably seen these before. Here is some of different ones. This is R minus 0. So that means the set of real numbers except 0. Sometimes we say R take away 0. The set of positive integers is also our natural integers, or our natural numbers, take away 0 or minus 0. And R minus Q is the set of irrational numbers. Now, sometimes this is written as Q double, this is double Q prime. So they can't be expressed in the form of A divided by B. That means repeating decimals. You also like pi, e, square root of 2 is repeating, things like that. All right, the complex numbers minus your reals. Remember, complex is the whole set. If you take away the reals, then you're just looking at the I. All right, so most complex numbers are A plus BI. So this is the real part, and this is the complex part. So if you don't want the real part, then you're just looking at the I. That means in this case, Y can't be 0. The universal set is a set of everything, and that's defined for a given situation. And the empty set is the set that contains no elements. Now, other common sets are the infinite set. So, for example, you might say, and I say this is double N, because that's how you type it in Microsoft Word. So, this is an infinite set. Also, if you said let A equal that other set, all numbers such that X is in between 7 and 10 inclusive, where X is a real number, that's an infinite set, because there's an infinite amount of numbers between 7 and 10. All right, so that's basically your common sets. Now we're going to talk about union. So let's say we have two sets A and B here, and here are our two sets. So the union of the two sets would be all the numbers together. So our union, and that would be written as A union B, would equal all these numbers: 3, 4, 5, 6, 7, 8, 9, 10. Notice we didn't duplicate these two. So it means it's a set of elements which are either in A or B, or in both A and B. So if we shade the diagrams, this would be A, either in A or B. It means everything here. All right? And we're going to make a note that A or the empty set equals A. There's a big note here. All right. So remember, the union, you can also read that as or. And then also A or the universal set is going to be the universal set. So it's always the kind of the bigger set. So we need to know those for set theory. Now the intersection, we have our same two sets. That's represented as A and B. So intersection is and. So if we do that set, that's just going to be our 7 and 8, because they're in both sets. All right. It's the set of elements which are in both A and B. And if this is A and this is B, then it would be these two here. All right. And then for our note, we notice that A and the empty set is going to give you the empty set, and A and the universal set gives you A. So we're looking at the smaller set on that as well. Now we're going to go to complement. So we have a universal set and we have set A. So the complement of the set A, so I'm going to write A prime, is everything in the universal set that's not in A. So that would equal 1, 2, 9, and 10. All right. Then we can also state that A or not A equals the universal set. A and not A is going to equal your empty set. These are important to know. Okay. We also have set difference. So set difference, and we'll call this A and B again. Set difference is like this: A minus B, or A take away B. So A take away B equals A and not B. So that means that elements that are in set A, so elements in set A that are not in set B. So here are the elements in A. So you shade that, but we have to take away the ones that are also in B. So we have to take that away, and it would just be this. Okay? The next one is symmetric difference. So this is written as A, we can call this triangle delta B, and this means A minus your B or your B minus your A. Remember, this is your union. Union means or. So this equals A and not B. So that's what that means. Or B and not A, or A prime. So this simplifies to A and not B simplifies as A or B, and then that's going to be minus A and B. All right, so these two are equivalent. So if we do a Venn diagram, that means everything here. This, why did I write B here? This is A. A and this. So this is your symmetric difference Venn diagram. When we're doing proofs later on, it's helpful to know what the Venn diagram looks like. All right, what else do we have? All right, let's talk about subsets. So for subsets, we have a set A, B, C, and D. And these are the different arrangements we can make. Again, remember, order is not important. So what we're going to talk about is if we have set A, if set A is contained in set B, then we can write that A is a subset of B. So this is written as A is a subset of B. Now the formal definition is if X is an element of A, then X is an element of B. I'll just write it this way. Then, so here's your if then. Kind of have a double thing going here. Then A is a subset of B. All right? The set of all possible subsets of A is called the power set. So we have a power set is all the power set of A. We can write as power set of A. So also, if we exclude this one, so if I take away this, then these are called the proper subsets of A. Of A. So also notice, if you can count these, there's a total from here to here, 16. And we have 4 elements here. So there's always 2 to the n possible subsets. So if there's n elements, in our case we have 4, 2 to the 4th, that means we have 16. And if we want to do proper subsets, that would be 2 to the n, and then you subtract 1. So for our proper subsets, we have 15 proper subsets of A. And that's it. Thank you. Have a nice day. Bye bye.